Hello, everybody. Mr. Schmidt here, and today we are going to work on angles using parallel lines. And there's going to be a lot of vocabulary here. One of the things that's interesting about this skill is it's something that you could probably guess a lot of the answers, but understanding why they work will help you be able to get some of those answers a little bit more consistently. So let's get started right away so that we can talk about what each of these individual terms means and how they can help us solve these problems. So the first couple terms we got to talk about are what are parallel lines and what are transversals, okay? So parallel lines are any line that travels that never intersect, okay? So as long as two lines are going infinitely in the same direction and will never cross, they are what we call parallel. A transversal line is a line that cuts or intersects two parallel lines. So for example, the one in yellow could be a transversal. However, the line in blue could also be a transversal. Even if I look at a line that's like this, where it doesn't cut through this line, but it would if it continues on, and as long as we are knowing we're looking at a line and not a segment, that would also be a transversal. So a transversal is any line that intersects two or more parallel lines. Well, that matters because when we have a situation with two parallel lines, which the symbol for parallel I'm going to use looks like this. So these two lines are parallel, making this line right here the transversal. What's interesting about this problem is when you do that, you create a set of four angles up here that add to a total of 360 degrees. But you also create the same set of four numbers. I just lost my mouse. Where'd it go? There we go. Down here. And you're creating the same four angles. Therefore, angle 1 is congruent to angle 5. And if people are getting confused by the congruent symbol, it's literally just an equal sign with a Superman cape on top of it. It means super equal. It means that they will be equal no matter what numbers you pick. Because they are both in the top left of these intersections, that makes them congruent. However, angles 2 and angle 6 are also congruent because they are in the top right of these intersection points. No matter what 2 is, 6 has to be the same thing. But also angle 7 is congruent to angle 3 because they're both bottom left. And finally, angle 8 is congruent to angle 4. And these are called corresponding angles. It means they have the same orientation on their portion of the parallel line where the transversal intersects with it. So top left angle equals top left, top right equals top right, bottom left equals bottom left, and bottom right equals bottom right. While corresponding angles are the angles we use most often, we also use something called alternate exterior and alternate interior angles. Okay, and before we talk about how we use them, I just want to define what interior and exterior means. So if we think of our two parallel lines as here and here, meaning that this line here is our transversal, the interior is what we think of as the inside of these angles. And so then the outside is the exterior angles. So angles 3, 4, 5, and 6 are inside, and angles 1, 2, 7, and 8 are the outside angles. Okay? And the reason why this matters is if I think of angle 3 and angle 7 as corresponding, which means that they are both equal to 70 degrees if they're if one of them is equal to 70, I then can actually solve the rest of the angles on the outside, because 7 and 8 have to be equal to 180 because they are a linear pair, or they make a straight angle. That means angle 4 has to also be that same thing. 6 then is a vertical angle with 7, making this 70, which would make 5 110. And we talked about this in the last video, that they all have to add to 360 as well. Now that also means then that angle 1 has to be 110 and angle 2 has to be 70. So now let's define alternate exterior and alternate interior angles. And the reason why we like these is because the alternate exterior and the alternate interior angles have to be equal. And let's show you why. So if we do alternate interior first, so that'd be the ones on the bottom, we look on the interior, and I see that angles 3 and 6 are congruent. Therefore, they are alternate interior angles because they're on the inside, but they're on alternate sides of the corresponding pieces of the transversal. So angle 4, its alternate interior angle has to be 5. Now, don't get too wrapped up in the vocabulary here, as long as you remember that you have the 4 angles on the left and the 4 angles on the right, and the corresponding angles have to be equal, then you're really getting the most important pieces here. I just wanted to see you to see the vocabulary. So alternate exterior, if I look at 7 and I go to the opposite side, the one that is alternate would be 2 because it's equal. So that would be angles 2 is congruent to angle 7. And then angle 8, its alternate exterior angle would be 1. But once again, we have the 4 angles on the right and the 4 angles on the left creates a set of equivalent angles. So now let's do an example. Let's solve some problems. So I have 2 parallel lines. I'm going to mark them here and here. And let's solve what we've got. So 40 has to be equal to y because these are vertical angles that are across the intersection. Therefore, angle y has to be equal to 40 degrees. Okay. Now, x is actually, there's 2 ways to solve it. X is a corresponding angle with up here, but it's also an alternate interior angle with y, meaning that x has to also be equal to 40 degrees. Z is then supplementary with x, so I do 180 minus 40 to get 140 degrees. Now, what most people do in these situations is they finish solving the rest of these pieces just to make sure that they haven't made a mistake and that the 4 corresponding angles on the top left match the 4 corresponding angles on the bottom right, which they do. So let's do one more. Our 2 parallel lines are here and here. And we know that this angle in the bottom right is 100. So what I'm going to do is I'm going to solve the rest of the angles down here and then use that to help us find all of the others. So I do this because each of these pairs are supplementary and have to add to 180. And then each of these pairs has to add to 180 as well. Meaning, if we look at the corresponding angles, so this angle corresponds with this one, meaning that B has to be equal to 80 degrees. This angle corresponds with D, so it has to be 100 degrees. The angle in the bottom left corresponds with C, and it also adds to 100 degrees. And finally, A has to be equal to 80 for many, many different reasons. Now, once again, remember, corresponding is the one that you're going to use most often, but you are going to hear the terms interior angles. Those are on the inside, and then exterior on the outside. Just also remember that the word alternate means on opposite sides. So if it's alternate interior, that would be like angle D and angle 100, or angle A and angle 80. So alternate interior, and then alternate exterior would be the same, except on the outside of those pieces of intersection. When you're working with the numbers on these problems, it's actually usually easier than the vocabulary, but we obviously want to try to understand both. If you have any questions, please let me know.